I think the easiest would be cookies, no? Like that's the easiest like pastry to bake. Yeah, but all some of your classmates said here that they can bake cupcakes, brownies. Oh yeah. And one of your classmates said here that as long as there's a recipe, we can all follow. Oh yeah, if you know how to read, therefore you know how to cook. Okay, so why did I ask you that? Like, what's the connection? Why is it that I'm asking you about baking? This is science, period, not TLE. Well, for today, kasi we will be baking a cake. And then, joke lang. We will look at a recipe um, in how to bake a cake. So let me show you here maybe the basic, no, basic ingredients in making a cake. Okay, so we need 1 cup of sugar, 1 cup of butter, 2 eggs, 2 teaspoons of vanilla extract, 2 cups of flour, 2 teaspoons of baking powder, and 1 cup of milk. So technically, these are the basic ingredients to make a cake. Okay, so if we will be relating it to what you were discussing, no, with Miss Manalang, about chemical reactions, we can like summarize the recipe, like the basic recipe, into this one. Okay, I'm so sure you are very familiar with this picture. You can see the arrows in there. You can see the arrow, the plus sign to indicate that you need to add it all up, like all the ingredients in here, so that you will be able to make a cake. Can you follow? But what if, girls? What if you will be baking 2 cakes? Okay, if you will be baking 2 cakes, what should you be doing to the ingredients? How much of the ingredients would you need? What should you do if you will be baking 2 cakes, vanilla cakes? Ayan. So you have to multiply the amount. You need to double up the materials and the ingredients. So technically, if we will be relating this concept of multiplying the amount of the ingredients into two, let's say, for you to be able to bake 2 cakes, we can like relate it, no, to what's happening in chemical reactions, and that is technically called stoichiometry. Okay, so just like the question or the scenario a while ago in baking a cake, when you say stoichiometry, uh, this is the process of solving for the amounts of reactants and products in a balanced chemical reaction. Okay, so if you have seen in the example a while ago, you need to double up the ingredients for you to be able to bake a cake. So just like chemical reactions in here, let's say the balance equation, no, to produce 2 moles of ammonia would be 3 moles of hydrogen. Like if you combine it with 1 mole of nitrogen molecule, you will be able to get or to produce 2 moles of ammonia. So if you can notice, or as you can see here, um, stoichiometry has something to do with ratio, ayan, wherein all the reactants are consumed. Take note also that there should be no deficiency in the reactants and there should be no excess in the reactant. So it's a ratio. For you to be able to produce 2 moles of ammonia, 2NH3, you need 3 moles of hydrogen and 1 mole of nitrogen. Can you follow? So just like in the cake a while ago, for you to produce 1 cake, you should need let's say 2 cups of flour, 1 cup of sugar, 2 teaspoons of vanilla extract to produce 1 cake. So just like that, in stoichiometry, we also focus on the ratio for you to see, for you to know the amount of the reactants and the products. Can you follow? Can you follow? Do you have questions? You ask me now. Okay, so we're clear? So you get the idea, okay, that this is ratio. So from this example, 3H2 plus N2 will yield to 2NH3, 2 moles of ammonia. So what if naman, wait, I'll make it big. I'll make the font size big kasi it's so small. Wait lang ha. O, di ba? Grade 10 na kayo, pero yung laptop ko hindi pa nag-upgrade. But anyway, what if naman, this is the scenario. There are 27 moles of hydrogen. So if that is the case, how many moles of ammonia will be produced? Like if you will relate it, or if you will maybe compare this lesson with your lesson in math about ratio, yung 1 is to 1, 2 is to 2, mga ganyan. I want to know, what's your idea on how to do this? For you to be able to see the ratio between the number of moles of hydrogen to produce ammonia, what should you be doing? Like, I want to know, what's your thought? What's your idea? How should we do this? Do we need to multiply ba? Do we need to add? Do we need to double up? Just like the cake a while ago? What's your thought? Okay, so one of your classmates said that maybe you distribute the coefficient, or maybe you multiply 2 by 27. So what are your other thoughts? And let's see no, if you are correct. So focus on the number of hydrogen in here. So what if you have 27 instead of 3? So let's say this is 27. So if that's the case, how many moles of ammonia will be produced? So how many? Wait lang. I'll make it blank. Blank NH3. How many moles if you have 27 hydrogen? Okay, so you need to find the multiplier. You need to find how many moles are in one hydrogen. Okay, sige. So let's see no, if you are correct. So if this is the scenario, here's what you need to do. Like technically, in stoichiometry, you focus on the ratio, no? So you should be able to take a look at the coefficients, right? So meaning, in 3 moles, wait, I'll change color. In 3 moles of hydrogen, 2 moles of ammonia will be produced. So if you will be writing it down into like a conversion factor like structure, so meaning 3 moles of hydrogen, H2, is 2 moles, ay, 2 moles of NH3. Okay, so technically, what I typed in here would serve as your guide, no, to determine how it's done, to determine how to solve for how many of the products will be produced. So what am I talking about? Let's see here. So if you have 27 moles of hydrogen, if you multiply it to the number of moles of ammonia, which is 2, well, based from your ratio, and then divide it to 3 moles of hydrogen, you will be able to determine the number of moles of the product that will be produced. Can you follow? So I will repeat. Girls. I'll give you time to copy in a while. So the given in the example here would be 27 moles. So what if you have 27 moles of hydrogen? How many moles of ammonia, NH3, will be produced? So using the ratio that I encircled in yellow, and also this. Ayan. So using the ratio, that will serve as your guide. That will serve as like your conversion factor in a way for you to determine what's the multiplier and where will you divide it. And from there, you'll get the answer. So 27 moles of hydrogen times 2 moles ammonia divided by 3 moles of hydrogen will give you 18 moles of ammonia. Can you follow? So if we will be canceling out the units, cancel, cancel, this will be it. 18 moles of ammonia, NH3. Okay, so we're clear with this. So again, if you are wondering, teacher, how do we know? How do we know? You will always base from the ratio. 3 is to 2. Like meaning 3 moles of H2. Here, I encircle in pink. 3 moles of H2 is to 2 moles of NH3. Okay? So, so there's a question in here. Teacher, is the like conversion factor constant? Actually, anak, it depends on the balanced equation. It depends on the reaction. Kasi di ba in the example in here, wait, I will clear, ayusin ko yung sulat ko. In the example here that I will box in a red. Look at the red box part here. This is the, ano ba yan? This is the balanced equation. So meaning 3 is to 1 is to 2. That's your ratio. Okay, so if you are wondering, where did we get the ratio between hydrogen and nitrogen and ammonia, sorry. Here, the one that I encircle in red. Ayan. So where did we get the ratio? From the balanced equation. Okay. This part that I encircled in red and also the box part, you will use that as a guide for you to determine the dimensional analysis. So it actually depends, no? The ratio actually depends on the balanced equation. Okay? Yeah, it's from the coefficients. Yes, it's from the coefficients. I will underline with purple. I will underline. Ayan, ito yung coefficients. This is where we will base the ratio. But it should be balanced, okay? It should be balanced. Okay. And then there's another question. Teacher, what about nitrogen? What happens to N2? What happens to N2? We're not yet done, anak. We're not yet done. We are only looking at the ratio between hydrogen H2. I will use white. Hydrogen H2 and ammonia. Okay, so we're only looking for these two ratio for the meantime. So we're clear? Are there some more questions before I proceed with the next one? No more? Okay, sige, next. So ito yung question ni classmate a while ago. So what if naman you have 27 moles, look at the bottom part of the slide. You have 27 moles of hydrogen. So how much nitrogen, how many moles of nitrogen will be needed, no, to produce 18 moles of ammonia? Ayan. So ito na yon. Wait. Sige, so there are some of your classmates who answered it already, no? So let's see. Wait, ayusin ko lang yung drawing ko, ha? Parang it's so colorful. So nice. So colorful. Ayusin ko. Okay. So for the second scenario or the second question in here, if you have 27 moles of hydrogen, how many nitrogen is needed? How many moles of nitrogen are needed pala to produce 18 moles of ammonia? So let's see. So 27 moles hydrogen times 1 mole of nitrogen over 3 moles of hydrogen will give you 9 moles of nitrogen. So, teacher, you're so fast. How did that happen? So again, this one that I will encircle in white, this is like your ratio. This is from the ratio here in the balanced equation that I will box again in red. Okay. So if the ratio of hydrogen and nitrogen would be 3:1, wait, I'll type it here on the right side. So meaning 3 moles H2 is to 1 mole N2. Okay, so that's like your guide already. That will serve as your like conversion factor for you to know which one to multiply and which one to divide. Ito. This one that I encircle in red is based from the ratio. And where did the ratio come from? From the balanced equation. Okay? Okay? So there's a question here. Teacher, does it have to be two significant figures? It depends on the given. Kasi diba 27, here 27 has two significant figures. So make sure that the final answer should have 2 SF as well. It depends on the given, anak. It depends. Ayan. So here is another question. So teacher, if you will be doing the ratio for the three of them, it would be 3:1:2, right? Yes, that's right. So if I will be typing it, wait, I will type it. So 3 moles H2 is to 1 mole N2 is to 2 moles NH3. There. So this is like the ratio based from the balanced equation. Okay? Questions? Are there some more questions? We're clear with this? Are you sure? Sige. So let's have another example. Wait, ay may pahabol yata. Wait. Teacher, how do you get the ratio again? Based from the balance equation. Look at the box, the red box. Based from that. Look at the coefficients, mga anak. Coefficients that I will encircle in purple. Ito. Coefficients. Technically, since N2 walang nakasulat, so we assume that it's 1. 1 yan. 1. But we don't type it. So 1, and then ito, 2. Okay? Sige. So I'll clear my drawing. Were you able to copy? Do you want to copy? Or you're done na copying? Okay, sige. So I'll clear my drawing. And let's have another example. So let's have the combustion of butane, C4H10. So in the combustion of butane, this is the chemical reaction. This is what happens in the combustion of butane. Combustion meaning there's the addition of oxygen technically. So butane, C4H10 plus oxygen gas will yield to carbon dioxide and water. Okay, so this is the equation to explain what happens in the combustion of butane, C4H10. And then the scenario would be this one. So in a particular reaction, 5 moles of butane are reacted with an excess of oxygen gas. So let's calculate the number of moles of carbon dioxide that will be formed in the reaction. Okay? So if we will be using GRESA, this is how it is. So we will write the given, which is 5.0 moles of C4H10 butane. We are looking for the number of moles of carbon dioxide that will be produced. Okay, but how do we determine that? How do we know? So again, we have to make sure that the equation is balanced. Okay, that was your discussion previously, right? Balancing equation. So you have to double check. You have to balance the equation out for you to be able to determine the ratio. Okay, so there in your notebook, copy this first and then balance the equation out. I'll give you 3 to 5 minutes. Copy and then balance the equation. Were you able to balance the equation? Have you been doing trial and error in here? Sige, last 2 minutes. All right, time's up. What did you get? So for butane, C4H10, what coefficient did you get in there? What number should we be putting? 1, 2, 3, 4, 5. What number for C4H10? Hala, what did you get? If you're not sure or if you don't want to annotate, maybe you can send it in the chat box. What did you get as the coefficient of butane, C4H10? The numbers are quite big actually. Secret na? Secret? Okay, sige. Ako na nga. Sige. So for butane, C4H10, I got 2. I got 2. Wait. 2 here. And then for oxygen gas, I got 13. So big, right? The number is so big, but that's possible. Okay, and then for carbon dioxide, I got 8. And then for water, 10. Yeah. Do you have the same answer? Yeah, I can see Lauren, she got the same answer in here. So that's correct. Or if we will be like double checking, no, if you want to double check. So if we see here, if it's balanced already, so multiply the coefficient to like the number of atoms or the subscript written below. So 2 times 4 for carbon, so this is 8. And then 2 times 10, hydrogen, so this is 20. For oxygen naman, 3 times 2, so this is 26. And then for the products on the right side, so 8 times 1, so this is 8. And then 8 times 2, so this is 16. And then for water, 10 times 2, so this is 20. 10 times 1, 10. So if you can see, it's balanced already. Because if you look at carbon, wait, carbon in the reactants, okay, in the reactant, so this is 8. For hydrogen, this is 20. And then for oxygen, we have 26. So this is for the reactants part, reactants side. Now what about for the products? So we have for carbon 8, and then for hydrogen 20 also, and then for oxygen we have 16 plus 10, so it's also 26. This is for the products, okay? For the products. So it's balanced already. So as you can see, for you to be able to determine the ratio, the coefficients, the number needed, you have to balance it out and double check really if it's gonna be the same, like when you add it all up. Per element, okay? Per element. Ayan. So technically, from our balanced equation in here, you will like get the ratio. Wait, ayusin ko lang yung drawing ko. Ayusin ko lang siya. So you will get the ratio 2 is to 13 is to 8 is to 10. Okay, so kung mahaba yung gusto nyo, di sige, mahaba. 2 moles of C4H10 is to 13, di ba, ang lalaki ng numbers, 13 moles of O2. O2 is to 8 moles of CO2 is to 10 moles of water, H2O. So this is like your guide already. 2 moles is to 13 moles is to 8 moles is to 10 moles. Okay, but we are not yet done. There's an here. There's a question. Teacher, do you mind to explain if your trick on how to do the balancing part? What's my like trick or my suggestion? I look at the one with the highest number first. I look at the one with highest number. And then I do trial and error. So since the one with highest number here would be carbon, so I start with carbon. So I have to make it 4, and then if it's not feasible, I adjust. Ayun. Be patient, mga anak. I know that balancing would really test your patience, no? But be patient, mga anak, talaga. Ang tawag dito? Persevere really in doing this one. Be patient in balancing it out. Just try to adjust, do trial and error, just like in math, so that you'll be able to get the balance equation. Kasi if you can see, aabot ng 13, meron pa nga minsan 20 yung coefficients. Yeah, so it actually depends. Just be extra patient in balancing. But that's my that's my way on how to balance it. I start with the one with big numbers. Ito pala, hydrogen. So I also start there, the one with big numbers. Okay? But we're not yet done, okay? We are not yet done because we have to know how many moles of carbon dioxide will be produced if we have 5 moles of butane. So here's how it is. Wait, I'll just clear my drawing. I hope you were able to copy that. And let's solve. Okay, so using the ratio that we got from our balancing part. So this is 2, and then 13 here, and then 8, and then 10. Ayan. So from our balance part, you already have an idea of what the ratio will be. 2:13 to 8:10. So that's what we will be using. So the number of moles of butane times the ratio to determine the number of moles of carbon dioxide. That's gonna be 4. So if you supply the numbers, here it is. So 5 moles of butane here multiplied to 8 moles of carbon dioxide divided by 2 moles of butane will give you 20 moles of carbon dioxide. Okay? So make sure that you cancel the units, ha? Cancel, cancel, cancel here. Ayan. Okay, so again, if you are wondering or if you want to ask me, teacher, how do we know 8 moles carbon dioxide divided by 2 moles of butane? You always look at the ratio from the balanced equation. Okay, this is where we got it. Carbon dioxide 8, and then butane 2. So 2:8. There. Can you follow? So for the final answer, there are 20 moles of carbon dioxide formed if you have 5.0 moles of butane. Okay? Okay? Do you have questions? You ask me now. We still have 2 minutes. I won't be your teacher after this. No, I think it's Miss Orminita. I think. Ayan. So you ask me now if you have questions. You wanna copy? Sige, yung copy. May 2 minutes pa tayo, mga anak. So there's a question here. Teacher, there's an excess of O2. Why is it 8 and not 13? O2? O2. O2. 13. Yeah. We are looking at carbon dioxide and butane in here. Yeah. No need to look at the reaction with O2 here because we are looking for the ratio between butane, C4H10, and carbon dioxide. Ayan. Sige, last 1 minute. Maybe there are some of you who are still copying. Then if you have pahabol questions, maybe you can send them now. We still have 1 minute. Okay na? Can you give me a thumbs up if we're clear? We're clear already? So don't worry because your next substitute teacher will give you some more examples no, on how this is done so that you can practice. You have notes in there that you can use as you prepare for the unit test on April. Okay? Sige. So since we're clear already, it's already 11:25. You will continue definitely in the next period. But I just want to let you know that I'm so happy to see you again, girls, and I wish you all the best. Bye-bye and thank you. See you again soon. Bye-bye.
Goodbye.